So welcome everybody, welcome to the EOcafe. This is our 108th EOcafe, and today we're talking about APEx, the ESA initiative. Normal rules apply. If you can keep your microphones muted, unless specifically ask you to join into the conversation. If you have questions, please pop them into the chat. We will take them with raised hands, but it's easier if they're in the chat first, then people know what's coming up and can prepare for answering. Also share information in the chat if you wish, if there's websites or anything that you want to signal to the people in the cafe. And that's about it. Or you please feel free to leave the camera on. It's always good to see people, but it's up to you. If you're doing other things or don't want to expose, then you can keep it off, of course. But it's nice to see people. I noticed we've got this EOcafe will be recorded, so I guess everyone had a disclosure to sign coming in. So ESA Application Propagation Environments, APEx. It's an initiative which aims to address the issue of sustainability, making research and development more sustainable. In other words, a phrase we often use, from research to business. To tell us about APEx, and whether it's APEx or APEX, I'm pleased to welcome from ESA Patrick Griffiths. And Patrick is joined by Dan Ormsby, also in the UK with Spark Geo, and Bram Janssen from Vito in Belgium. So let's kick off. Maybe you can just very quickly introduce yourselves. People know who you are. Patrick, can I ask you to go first?
Hi, good afternoon and welcome everyone. So I'm Patrick Griffiths. I work in ESA and EOP in the science department of EOP. It was based in Esrin for many years, now in Exap in Harwell. I'm also the technical officer and the initiator of the Application Propagation Environments initiative, and I'm happy to be here today. Thanks.
Hi, good afternoon, everyone, and thank you for the opportunity to speak a bit about APEx today. So my name is Bram Janssen. I'm working at Vito Remote Sensing, which is a research institute in Belgium, and I'm acting as a project manager for the APEx project here.
Hi, everyone. Yeah, I'm Dan Ormsby. I work at Spark Geo. We're a Canadian professional services company with a UK subsidiary that I'm responsible for. We're involved in the APEx project in the development of one of the tools that forms part of APEx, the Geospatial Explorer, which I think we might be talking about a little bit later. And yeah, thanks for inviting us to join this event.
So thanks to you all, and thanks for joining us today. And yeah, I'm sure we'll hear more in a moment. Transforming R&D outcomes into business is a challenge in most, if not all, sectors. Claude tells me that as a rule of thumb, 60 to 90% of R&D spending does not lead to exploitable results. 10 to 30% does lead to some return, but only a small subset of these turn into real business, generating significant profits. So with this in mind, APEX has been created with the goal to try to improve the success rate by supporting the exploitation of EO-related R&D projects. Many of the research projects, I'm sure that many of you in the cafe today participate in those projects or lead projects, and they are developing algorithms, data sets, different tools, knowledge, but these often disappear or remain difficult to access, difficult to reuse once the project comes to an end. And so APEX aims to bridge this gap between the research, EO research and development, and the operational services and long-term use and sustainable business. So instead of every ESA project building its own IT infrastructure, APEX provides a reusable environment and operational tools that projects can focus on their core goals. And this is part of the broader ESA push to increase the use of EO data, accelerate commercializations, develop a European capability, and improve operational uptake. It was launched in 2024. It's intended to become integrated into ESA's long-term network of resources infrastructure, which is something also that we should get an update on sometime very shortly. We talked about it quite a lot some years ago, I remember, but it would be good to get an update on that. But that's probably about the extent of my knowledge of APEx. So let me hand over to Patrick and the colleagues. Please tell us more about it.
Yeah, thanks, Jeff. So I think you already outlined the background and motivation here quite well. You know, this research and development problem that we have in Earth observation to bring these innovative solutions that we develop in the R&D world into more operationally used solutions. So from an ESA perspective in the science department, you know, we initiate tens or hundreds of projects per year. And, you know, over the past decades, I would say, you know, there was rarely a case where the results, especially the algorithms, the application algorithms, or the static value-added products are preserved beyond the project duration. So this is really a key problem. And then also for deliverable documents and stuff like that, you know, I mean, there would be a big benefit if we could sustain this for the community to make it accessible and reusable, right? So that's really the one realization. The project results disappear after project funding ends, and then, you know, maybe we reinvent the wheel by initiating another project on the same topic instead of building on top of what has already been achieved, right? So that's really a fundamental issue. The other thing that we realized is that we don't really have a mechanism for this last kilometer challenge, right? To bring research and development solutions to an operational state so that they can be taken up by non-space industry sectors for operational use. That was the other thing. And then the third motivation, you already outlined it, is that we have, we can make available flexible off-the-shelf software components that support projects in their project development, implementation, but also the promotion of the results. And that's what we're doing with APEx. So you already, so I cannot tell you if it should be APEx or APEx. I think that can be up to anyone to decide. But you already said it's a really transversal initiative in EOP in the science department. So it's working with a lot of projects that we're running. It has a 2+3 year funding horizon currently, but we're planning to make this way of working in APEx sustainable in the science department. So that's important to know. The core APEx services and solutions are implemented by a core consortium consisting of, you know, Vito, SparkGeo, Brockman, TerraDua, and now we're adding Development Seed and ThriveGeo to the core consortium. But what we're really trying to build is a federation of fair, compliant services and solutions across the European ecosystem. You know, I mean, this whole fragmentation of the Earth observation cloud platform landscape has been an issue. It is still an issue in Europe. And, you know, adhering to fair compliance to make sure that things are findable, accessible, interoperable, and reusable is really important. And that's a key motivation and objective in APEx. So, you know, I want to just underline again that APEx is not a processing platform. It's much more streamlining existing resources in the platform ecosystem, making sure that these are interoperable and fair compliant, and integrating them in a streamlined way so that the community gets a more unified and integrated solution for using Earth observation algorithms, accessing value-added products that we generate in our projects, and so forth. So yeah, that's the background and motivation for APEx, for the application propagation environments. And now I can talk a bit about how we do that, and then I think Dan and Adam can go, Dan and Brown can go a bit more into detail here. So with APEx, we are developing two groups of solutions. One are called the algorithm propagation services or algorithm propagation solutions. The other ones are the APEx project environments. So the idea with the algorithm propagation is really to take the application algorithms that are developed in our projects and transform them into really fair, compliant, cloud-based, on-demand algorithms that can be reused in a scalable way without you having to deploy this anywhere on an infrastructure, without you having to download data and all of that. So that's really core part of the algorithm propagation services that we're developing. And the specific tasks that we work on there, that we support projects with, is, for example, the porting of the algorithms into one of our interoperability best practices. So we're working a lot on OpenEO API, which is really made for federated ecosystems to make things work across federated remote resources. We also support teams in optimizing the computational performance of the algorithms. So a lot of the research and development algorithms that result out of ESA projects are not made for production. And sometimes we need to scale these algorithms, and the cost estimates are horrendous. And then we go into a phase of computational optimization to bring the processing and infrastructure requirements for these algorithms down quite considerably. We also support the teams with packaging and porting the algorithms following the other interoperability best practice, which is the OGC Earth Observation Application Package Specification, which basically works together with the OGC API processes compliant APIs. So these are the two interoperability best practices that we are promoting and using. And with APEx, we provide a number of guides, tutorials, and other resources and tools for these teams to work on the algorithm propagation, to make their algorithms available in this way. And we're also providing, of course, expert support, so from our developer team, helping project teams also in proactively porting the source code from their native implementation into one of these interoperability best practices.
So just to help me understand there's a catalogue of what's available that people can go and browse through and find results that have been developed elsewhere that they can bring into their own projects?
Yes, exactly. So in the context of the algorithm propagation, there's two key resources that I wanted to introduce. One is the APEx algorithm catalog. This is really a catalog of on-demand algorithms that are hosted in the cloud, that are running on different platforms, but they're all adhering to FAIR principles. So all of these algorithms can be executed through different execution interfaces, and they're running on different platforms, and they are offered in the network of resources also at a commercial level, and in some cases can be sponsored by ESA. So that's one of the key resources here. And I think Bram will go a bit more into detail on the algorithm catalog. I think one important aspect is also that these algorithms in the algorithm catalog are performance benchmarked and continuously monitored for their functioning. So what we're also trying to do here is to build a bit of trust and certification of these algorithms that we're making them available, because EO marketplaces have been around for 2 decades at least, and at least in my experience, there's never been any really meaningful solutions in there. So that's what we're trying to change. So that's the one key resource in the context of the algorithm propagation. The other key resource that I should speak about is the APEx product catalog, which is directly linked to the so-called ESA project result repository. So this is really a stack-based, open, publicly accessible catalog and repository for static value-added products that we generate in our projects. So you can imagine there's a lot of geospatial products that we generate in ESA projects. They have typically disappeared after the project ends. And now we have a ESA-managed, ESA-operated, long-term data repository where we store these results and make them accessible to the community. So currently it's about 80 terabytes, but we're expanding this to 450 terabytes. And it's important to understand that all of the ESA projects that we initiate in EOPS under the Earth Action programmatic line are required to integrate their products at the end of the project lifetime into the PR, into the project result repository. And they are obliged to develop the application they're developing following the APEX interoperability guidelines in an interoperable and FAIR compliant way, so that they're available to the community to try out. A lot of the algorithms are running on CBSE, as this is a major platform and data center for Earth observation, but there's other platforms that are supported as well. So that's for the algorithm propagation, the key parts, but I think we should hand over to Bram in a minute to explain a bit more the algorithm catalog and maybe also other aspects like the upscaling service that we're working on. That would be great. Let me just quickly introduce the concept of the project environments. So there, the idea is that APEX provides some off-the-shelf software as a service solutions that we can deploy for a project that requires them in an integrated way. And these components include, for example, simply a web portal, a Jupyter Lab environment, a data catalog, a user forum, and a geospatial explorer, which is the web GIS tool, the visualization tool that Dan and colleagues have developed. And these components, so projects can approach us, they can tell us which components they require, and Brown and colleagues will simply deploy this for them in Open Telecom Cloud, part of OTC, part of CDSE. And the project teams are then in charge of curating and maintaining this project environment. And these project environments are basically pre-configured to work with the data sets that we're aggregating through APEx and the algorithms that we're making available. So you will have these algorithms pre-populated in the development environment. You will have these data sets easily accessible for the Geospatial Explorer. And yeah, the idea here is really that we support project teams to go very quickly to full speed without having to redevelop something that has already been developed elsewhere. And you know, again, these all of these services are in the network of resources where we offer them at a commercial level, but then also through ESA sponsorship to de-risk the uptake for any stakeholder that's interested in reusing them. So I think I'll stop there, but maybe we should give Bram and Dan the chance to introduce these key resources that I introduced briefly a bit more in detail. So maybe Bram, maybe you want to talk a bit more about the specifics of the APEx algorithm catalog and maybe also what the benefits are for projects and companies to integrate their algorithms there.
Yeah, definitely. I maybe even want to go like one step back even and explain also a little bit why we are focusing on these interoperable standards such as OpenEO and the EO application package, as it will make sense on the thought process behind our algorithm catalog and what we're actually doing there. Like Patrick mentioned, one of the big challenges is addressing that last kilometer challenge. And this is where you typically have your R&D results, right? Where you have like a complex environment that you need to set up to actually run the algorithm that has been developed. It requires you to have the environment there, the dependencies need to be in place. And only if all of those checkboxes are marked, then you can start executing your service. Maybe you need to fetch some data as well. And this is becoming like a very important hurdle for this last kilometer challenge. And so that makes it what comes out of these R&D projects are not really ready to, for example, to be integrated into an existing business workflow or a commercial workflow. Because you need to have that background knowledge of Earth observation and all of these complex concepts that are related to this. With the work that we try to do with APEx, by focusing on those interoperable standards, like Patrick mentioned, we're actually trying to transform this complex algorithm environment into something that is deployed on a service and available through an API. And an API is really a structured way that you can, that allows you to integrate in a very structured way the outputs of a service and also trigger it into another existing workflow. Many of us who have been working with existing business workflows, they know the concept of APIs, and typically a normal developer who needs to be integrating these kind of things into existing workflows knows how to work with this. And because we're focusing on two interoperable standards in this case, OpenEO and the EO application package, it means that if you know one of those two, or you know both of them, then you can actually implement or integrate any service that is based on that standard. If you know how to integrate the OpenEO API, then any service that is built on OpenEO, you can easily start plugging into existing parts of a workflow. So that's why we focus also on these two interoperable standards, really to make it easier to address this last kilometer challenge, making sure that you have an API. You don't need to have the complex environment behind this. This is all abstracted by the platform that is actually providing you access to that API. So, but this is also a bit of a shift in mindset for many projects, because it's mostly they stopped with developing this algorithm, but now we are helping them with taking that algorithm and deploying it on an existing cloud environment. And this brings some challenges with it. This is you need to know how a cloud environment works. You need to know a bit how to optimize your algorithm to work on a cloud, to work on a large scale. And this creates some challenges. And this is where APEx is actually here to support. This is these propagation services that Patrick was talking about, is that we can help in that transition. And a nice result of all of the work that we have been doing in APEx is actually our algorithm catalog, where you can actually see all of those exercises that we have been doing in the past 2 years of initial contract, where we were helping projects with transforming their algorithm into an on-demand service, where at the end, at this stage, we have 43 different services that are there. They are services that you can start using. They are on-demand services that are deployed somewhere, that either are available through an Open EO API or deployed as an EO application package, ready for you to start working with this. The nice thing, and that is also what Patrick mentioned, is this algorithm catalog is not served as being, or it's not built to be like another yet a marketplace. Most of the marketplaces that you can find today, they are really focused on publishing services from a specific platform, from a specific technology. So, for example, on CDSE, you'll find the CDSE services, you find OpenEO. But if you want to use something else, you need to go to a different platform, look over there, see if you can find whatever you're looking for. What we try to do in APEx is really consolidate those resources into a single location and provide a consistent way of showcasing these services. Amongst those 43 different services on our algorithm catalog, we have 6 different platforms where they are all hosted. Again, still only based on those interoperable standards, OpenEO and EO application package. They are all visualized in the same way. So you can look through all of the services that are on there, see who has developed it, where it is available. You can find details. And if you open one, you also already have the details of the service, the description, but you also have direct links towards that platform so that you can actually, with one click of a button, go to that platform and start executing that service, start using it. For example, if you would go to an OpenEO-based service on CDSE, if you click the button, you're redirected to the CDSE OpenEO web editor, where you can actually just go through a wizard, fill in the parameters, click the execute button, and start using that service. Same goes for the other ones. If you use one that's on the GeoHazard exploitation platform, you can click the button, and if you have access to that to the JEP, you can start using that. And the nice thing is that these platforms that we use to host all of the services are all integrated in the network of resources, which means that you can actually go to the ESA network of resources and ask access to that platform if you don't have access already. Not only do we do this directly linking to the platform, but the nice thing of working with these interoperable standards is that you can build many kind of different other integrations on top of those standards that would work for all of the services that are using that specific standard. What we also do, for example, is we integrate notebooks, so that you can actually go open a notebook and if you want to in a programmatic way access that service or execute that service, you can click on a notebook if it's linked to that service, go to a nice Jupyter Lab environment from APEx and start using that and see how you, for example, can use the OpenEO Python client to execute any kind of service from the algorithm catalog. Another thing that we are also working on, and which is a nice example of how you can actually exploit these standards and building tools on top of this, and this will probably also be a bit highlighted a bit more by Dana, is that we can also start building this as a in any kind of visualization software that you have a graphical user interface where you can just fill in the parameters independent of the underlying platform. Click a button again to start processing, executing that service. And this is what we are also developing in APEx and integrating in the Geospatial Explorer, of which Dan will talk soon. And so really exploiting these standards as much as possible. And another thing, as well, is that based on that, we can also build tooling to do automated benchmarking, also mentioned by Patrick. And this is something where the APEx catalog is really differing. It differs a bit from all of the other marketplaces as well. Is if an algorithm provider wants, we can start testing their service at regular times. So what we then do within APEx is we take a service that is there and we start executing it based on a set of parameters, a benchmark scenario that is provided by the algorithm provider. We execute that service on the platform and actually see if it's working and if it's returning back the result that is expected. And this is a very nice feature. Sorry, Jeff.
Maybe that's a good point to hand over to Dan to explain a bit more about how that's working.
Sure.
Yeah, thanks, Bram. Dan?
Yeah, sure. So so I think what we've done is we developed one of the project environment tools. I think Patrick has just shared the link actually of what some of those project environments are. This suite of tools, things like kind of documentation portals, user forums, web portals, etc., that really help kind of projects help kind of engage with their stakeholder community. And one of them that we have worked on is the Geospatial Explorer. So I think generally it's kind of well known that using kind of web GIS tools is quite a nice way of providing really kind of instant access to outputs of kind of EO R&D projects. It's very easy to access, very compelling in terms of being able to sort of visualize data. Using different kind of visualization methods, and that might include maps, but charts and graphs and statistics and time series controls and all these kind of things. It's and it's a really great way for kind of EO projects to kind of share their results with users and stakeholders in a very compelling way. And there's some really great tooling out there. There's some fantastic open source libraries, things like kind of OpenLayers and MapLibra and Leaflet and things like that. But a lot of those kind of tools need you to actually write some software, do some development to actually, kind of make them work with your data and the functionality that that is useful for your particular use case. So what we've really tried to do with the Geospatial Explorer is to provide a kind of a platform that allows you to sort of publish your results through an interactive kind of mapping system without really having to do any of that development. So it's very much a kind of no-code solution. And the intention really is that you can just through configuration, you can spin up a web map environment that allows you to share your data. You can determine exactly how it's visualized, what sort of functionality is included with particular data sets. Whether this one has a particular way of visualizing it that's relevant to your target audience, or another data set might be best served up as a kind of time series. Another you might want to have some filters on, some constraints on, and it kind of allows you to essentially kind of build your web map front end, without having to do any development and just using some of these configuration tools. So it's really aiming to make that a really easy and also a very kind of low cost system for you. So you can kind of just get your results out there. So we've done essentially if you ask for a Geospatial Explorer to be part of your project's environment, you get kind of provided with I guess what's like a sort of an empty canvas into which you configure your data and configure your the functionality that you want. The data is anything that you can effectively host publicly in any kind of cloud storage, but also if your data has been onboarded to the project results repository at APEx, then it's very easy just to kind of hook straight into that as well. One of the things we've done as well with the Geospatial Explorer is provide a user interface to do that configuration. So we call this the configuration builder. The actual configuration of these Geospatial Explorers is in what's called a JSON file, which is basically a structured file that determines how your GE is presented. But run people who are trying to build these configurations have to understand their way around JSON and this sort of slightly complex sort of technical format. You can just use the GUI to build up the UI in the way you want to. I think there's some examples on the solutions gallery that Patrick shared earlier of some people who've done this. So there's some different Geospatial Explorers there, and you can see the sorts of kind of outputs that they've been producing. So I think that's kind of where the Geospatial Explorer is right now. One of the kind of major features that we've been working on recently is now providing seamless integration between the Geospatial Explorer and the algorithms environment of the on-demand algorithms that Bram and Patrick have been talking about so far. And we'll be doing a release, pretty soon, hopefully in the next couple of weeks, with that capability added in. And the reason I think that that's really exciting is that it now means that not only can you say, right, here's a web map interface that shows examples of our outputs of our projects, but you can actually get users explore the algorithms themselves just by executing them from within the Geospatial Explorer. So I was doing a factual demonstration to some colleagues in Canada yesterday and kicked off an algorithm of a town in Canada that looked at the urban heat island effect. So just sort of click and put in a area of interest and time of interest, hit go, and a few minutes later there's the analysis complete. And that's really exciting, because I think that allows you to sort of bring outputs of R&D projects really to life. It's not just saying, right, here's a bit of data that you can download. You can say, here's some data that you can see, some example data, you can interact with it, and now you can even run it on your own area and your own time of interest. And I think that's kind of really exciting. And what we've done by integrating the GE into the algorithm catalog is essentially allow you to sort of run a whole load of different algorithms, so outputs from different ESA-funded projects in different domain areas. And I think that's a really kind of powerful tool in terms of helping communicate the valuable outputs of this EO work. Jeff, sorry, I had a question.
Well, I'm wanting to let it flow, but at the same time wanting to interrupt, and there's quite a few interesting questions coming in. I almost came in before, because if people are going to start using this, which obviously when we can talk about the profile of users and how many users you have, what is the commitment to it from ESA? What can people rely on it and being there in 1 year, 2 year, 10 years time, and what's the sort of the support commitment? I guess alongside that, what are the criteria by which it will be judged whether it is funded for a longer term or not? Patrick, maybe you want to comment on those?
So we have budget secured to continue this until 2029 as a minimum. Mm-hmm. But as I said, we're trying to establish this in the science department of EOP as a way of working. So this could really be a transversal mechanism to facilitate all of the project R&D work that we're doing and to promote it. So that's the goal. But I would also like to highlight that, by building on these interoperability standards that we are using, we are making sure that these things live on independently of APEx even. All of these algorithms, they're interoperable for a good reason, so that they're not locked in to a specific environment, right? With OpenEO, you can run these on any cloud backend that supports the API and that has the data in a fairly accessible way. So even if APEx were to disappear in 4 years' time, these things will live on, because they're all made to be interoperable. And also the Geospatial Explorer, it's as Dan has introduced, it's a browser-based WebGIS client that can be used, fairly independent of this initiative. So I think we're building really, fair, compliant resources that are independent of the APEx initiative project funding. But we have secured funding for, over 6 years, which is already unusual maybe for EOPS projects, I would say. So pretty good. And I think if we can this is a good way of working, then we will find ways to ensure this on a longer term than even 2029 horizon.
Okay, I know Emmanuel Mondon had a question around SLAs, which is a bit similar to that. Emmanuel, do you want to develop that further?
Yes, good afternoon. Thanks a lot for this super interesting cafe. Let's assume I am a service provider. I'd like to provide an operational service, and I'm wondering if I could rely or develop on APEx. There are two topics, a technical one, I don't have any doubt about it, and I would say a legal one. Legal meaning I need to commit myself as a service provider to my customers a service level agreement. I can do that only if my backend, my technical partners on which I'm relying on, are able to provide to me a service level agreement as well. So my question was, is APEx offering a service level agreement? And if yes, what it is and who is behind? Who is from a legal entity point of view? Thanks.
Yeah, it's a good question, Emmanuel. I saw you had a few other good questions in the chat, so I hope we can address them all. But first of all, let me remind you that APEx is not a processing platform. It is federating existing assets in the ecosystem. However, all of the projects, all of the platforms that we're federating with, that we're working with, they are listed in the ESA network of resources, and as such have an OLA and SLA in place as part of their commitment to the norm. So that's one aspect. The other aspect that I mentioned is we want to build trust and an element of certification on the algorithms that we're making available. And that is, of course, something where APEx is doing this benchmarking, ensuring that things are working technically, scientifically. And of course, a lot of the algorithms come out of EOPS science projects. So they are validated and quality assured. And then I guess another thing that we can mention is that some of the algorithms that we aggregate and make available through APEx, they are provided by algorithm PIs that are themselves not platform operators, but rather research companies or research institutes. And there we're exploring also new business models in a way, because these research institutes that have developed an interesting algorithm, they might deploy this algorithm in one of the existing platforms and kind of set up a revenue share agreement with that platform operator to take over the operation of this algorithm to ensure its availability in the frame of their OLA and the SLA commitment to the network of resources. So this way we also enable different research institutes and companies to share their algorithms without being a platform operator, which is really good because that enables a large part of the community to share these algorithms in a reusable, fair, compliant way.
Thanks a lot. Thanks, Patrick. Great.
We'll come back in a minute, Emmanuel. I wanted just to turn to Alessandro Marin, who has sort of a very technical question, before coming back maybe to some of the more questions of IPR and legal stuff. Alessandro? Is Alessandro there?
I think he may have.
He may have left.
Yep.
Yeah. Okay. Wolfgang, you had I think maybe the first question was answered, but you then had subsequent ones. Wolfhard, sorry. You're muted.
Can you hear me now?
Yep.
Okay. The other two questions, the first one, yes, was kind of answered. Still, I would like to raise this maybe in another context, maybe in another form. But the two other questions are about a forum functionality, and Emmanuel already asked back then if I meant that this should be kind of a community platform. What I was looking at is there a possibility to really have a, how should I say this, a kind of a search algorithm and an exchange algorithm that directs questions from potential users of those R&D results to maybe the right point of contact, or maybe even allows putting in a question like, okay, we need this and that kind of solution for a certain technology that we are developing. Is there anyone around developing something like this, having something in the pipeline, some research institute, some other company? Could there be some kind of a forum functionality? And then to just ask my second question or next question along with that, if I want to use then technologies, algorithms that are posted on APEx, that are made available through APEx, what about the licensing issue? Because a lot of it, if it's not just published public entity, public source research that is available to everybody due to publishing, what about the IP that I'm putting onto this forum? How's the licensing going to be handled?
Brian, would you like to take this one? Otherwise, I can expand a bit.
Sure. So on the forum part, I think APEx is already working inside of that direction, in the sense that what we try to do as much as possible is to engage with all of our stakeholders and all the projects that we are working together with, and actually using our APEx forum to collect these kind of ideas, and also bring in the users in contact really with the technical experts and the people that are building those services, but also the people that are, like, for example, the team of Dan, where if they want to have additional features in specific tools, that they can go there. So from an APEx point of view, we're kind of trying to set this up to bring stakeholders and the community towards the experts, linking them together. But we still see that, I mean, this is still a big activity and a lot of challenges there, because we, like with the different platforms with the different services, you also have different forums on all of these different platforms. And so even on that level, it's also still a challenge to streamline everything. But an initiative such as APEx is one way of trying to do that. Regarding the IP, one of the important things as well is that from an APEx point of view, we don't require everything to be open and publicly known, publicly shared. Both from a platform perspective, let's say, platforms that are onboarded on APEx don't need to be publicly available. We don't enforce any business models on platforms that are on there. Each platform can still employ their own business model, requiring people to buy access before they can start executing that service. And we also incorporate that into our APEx algorithm catalog as well, making it sure that you need to request access. So that's something that we try to avoid with APEx. Really, we're not putting any business rules on there. From a service provider point of view, it's kind of the agreement again that you make with the platforms themselves on the IP. From APEx point of view, the IP always stays with the service provider. So APEx does not take any of the IP, and it's the agreement that you make with the platforms where you host it. For example, we had one where we hosted it on CDSE, where the service provider said this is code that cannot be publicly available. And we ensured that the code is encapsulated in a way that the user at the end would never see what's happening behind the scenes. And so, again, from an APEx point of view, we don't put any restrictions or rules on that, let's say.
Can I just add maybe two thoughts on this? So on the one hand, what Bram just mentioned, fair compliance does not always involve open source. So you can be fair compliant, but not fully open source. And that's what we're aiming for, because of course we want to support business models of companies that are proprietary, at least in parts. So fair compliance does not always imply open source, full open source. That's one thing. And well, the other thing is that currently, if users want to make use of the APEx algorithm catalog, they have to ensure access credentials to the platforms where the algorithms are running on them by themselves at this point. In the future, what we're kind of aiming for, I think, is also to strongly integrate APEx with the network of resources, so that at one point, APEx will broker license credits and access rights through the network of resources for all these platforms, so that even the consideration of credits and license conditions are kind of abstracted from the user. That's where we want to go, but that's still a bit of work until we're there, I think.
Thank you. That I think makes it very clear. Thank you very much.
So what are they? It's mainly technical people that would be using the platform. As developers, Earth observation people, or application experts? Where do you see the main sort of users coming from?
Yeah.
Background?
Yeah, I think for the algorithms that we're making available, this is supporting the community on developing new innovative applications, right? Instead of having to reinvent a agricultural parcel delineation algorithm, use one of the 2 or 3 solutions that we're making available and integrate it into your application. You know, we're offering operational analytical building blocks that you can plug into new application algorithms, right? We want to really advance the application development and innovation in the Earth observation sector at large. Then, of course, the project environments are primarily for ESA projects to allow them to focus on the actual R&D work that they should be doing and not on reinventing a web viewer, even though we have a very nice off-the-shelf solution that can be reused, you know. But, you know, these project components are also available for any company or institution that wants to use them at a commercial level. So that's also possible.
Is it just ESA projects, or running a Horizon project or a national or even a sectoral project? They're able to use the system as well?
Yeah, I mean, absolutely. The algorithms, the product catalog, the algorithm catalog, all of those are resources that are free of any you know, license conditions or user rights, or so they are absolutely usable. The project environments are currently, you know, funding is secured for ESA projects. You know, we support ESA projects at many, and we're scaling up. But, you know, all of the services are offered in the network of resources, and that implies that we're also offering them at a commercial level. So if company X would like to use an APEx web portal together with the Geospatial Explorer and the Jupyter Lab instance, they can pay for it through the network of resources and make use of it. The question of you know, supporting also Horizon projects in the future, we discussed it previously, and that would of course be very nice, but we have to identify an appropriate mechanism. At a commercial level, it's already possible, but you know, it would be nice to also de-risk the Horizon projects and uptake of these components and solutions. But that probably requires a bit more thinking, but we're open to it for sure.
Okay, so people should just be in contact with you if they have further interest to.
Absolutely, yeah, that'd be great.
Yeah, Emmanuel has, I think, put several questions in about links to other programs and other platforms. Emmanuel, do you want to develop something around that?
Yeah. Indeed, I spammed the chat. Sorry, but there is a feature you can save and download it. Yeah, I'm paying attention to the outside world. The Earth observation ecosystem is great, but we should pay attention to the outside world. And I have two questions regarding the outside world. Do you already have links, interface, whatsoever, with the common European data spaces? That's one. And I was mentioning as well EOEPCA, but I saw that Richard Conway replied to that, and there is an obvious link between EOEPCA specification and components and APEx. So maybe you could mention the outside world. So all the initiative supported by public or private entities, national or European, related to data sharing, which are eager to access to information derived from space assets, including Earth observation. But therefore, we need to adapt to them and not the other way around.
So I think with all of the APEx solutions and services that we're building very much on federated data access models. And we don't have an explicit link that we created to the European data spaces, but we hope that they build on the same technologies that we are building on, which is Stack for metadata and cloud-optimized formats for all sorts of geospatial data. And that allows us to stream data sets rather than the old model of having to download and deploy data sets. And that is working really well these days. So we can, even within the European platform ecosystem, we can access remote data sets through Stack and through cloud-optimized formats through the internet very efficiently. And for the Geospatial Explorer, it works beautifully for visualization. For processing in OpenEO through LoadStack, it works really well. So, I think it's hopefully just a matter of connecting the Stack catalogs to the European data spaces. But I haven't followed those initiatives in detail lately. So, yeah. And then maybe the other question was regarding EO APEx, so the common architecture, the Earth Observation Exploitation Platform common architecture contract that we also have in the science department, where we're developing interoperable building blocks, open source building blocks for platforms. That is very closely linked to APEx. And actually APEx is one of the main stakeholders for EO APEx, influencing and providing requirements for the open source building blocks that we're developing in EO APEx, so that new platforms that are available that want to federate, that they can adopt these building blocks and they right away become interoperable and these systems work across the internet. And for platforms that are interested in federating through APEx, they can also be added to the EOAPEX Common Architecture Initiative as a use case to support these platforms to become fully interoperable. So very closely linked, like the network of resources.
Okay, thanks. There's been quite a bit of traffic in the chat. If I've missed anything, can either raise a hand or signal in some way if you have a further question that either I've missed or something that comes to mind. So I rely on you to signal there. But in the meantime, I just wanted to say, well, what's happening in the near future? Where's APEx going? What are you planning to be doing in the next 12 months?
Yeah, we're about to kick off the APEX Phase 2, which is the next 3-year extension with almost €5 million budget, which is for ESA projects fairly large, for Horizon projects smaller, but we're quite efficient with budget. So we have a few really cool ideas on the table. I mean, I let maybe Bram and Dan maybe highlight their favorite, but I mean, we're looking at integrating large language models for, as coding assistant for OpenEO, for CWL, for Stack. We're also thinking about agentic use cases with LLMs, using the different resources we're making available through APEX. We are integrating the OpenEO T-tiler solution in a very deep way, so that OpenEO process graphs don't even have to be executed for batch processing anymore, but they're evaluated on the fly while you pan and zoom around the visualization solution, which I'm really looking forward to. But maybe I'll let Bram and Dan pick one highlight of the evolution work that we're going to do over the next 3 years.
I think you highlighted already a very nice use case. Again, with looking forward with the integration of these LLMs and the agentic framework really being able to add another abstraction layer on top, let's say, where you don't even need to know about the API or implement something. You can just ask the question, and the system behind it is hopefully smart enough to pick the services from the APEx algorithm catalog and formulate an answer. That is really something that I think can also have a big impact in this downstream integration. So really looking forward to that feature.
Yeah, I think on the Geospatial Explorer, I mean, sort of, we've already covered a few of those points. I mean, I'm really excited that we'll be releasing the sort of integration to the algorithm catalog really soon. And as Patrick has said, we're kind of going to be opening some new doors as well with kind of integration with T-Tiler with an OpenEO backend as well. So that's going to be some quite exciting stuff in terms of what we can do kind of on the fly through the Geospatial Explorer environment. I guess the other and some of the other things like kind of agentic AI, already has been mentioned. I guess the other thing which we wanted to do with the GE as well is I mentioned earlier, we've got this kind of GUI that allows you to sort of build your configurations and deploy those. We're going to be progressing that quite a lot as well to be able to make that a more of a kind of collaborative activity between kind of multiple contributors, and a bit like the way you can, if you're using sort of, the Google Docs or something, or Microsoft or whatever, you can sort of share documents with different sort of permission levels, and we'll be doing a kind of similar thing with the configuration builder as well, that you can have sort of multiple people collaborating and contributing around something. And I think that might open up some interesting kind of collaboration opportunities. There's one of the things we haven't really mentioned much is there's a group called the Stakeholder Expansion Facility, which is actually an ESA initiative that is going out and really kind of promoting the activity of ESA-funded R&D across lots and lots of different projects, but around particular thematic domains. So they're kind of doing that as one party, but I'm also wondering whether this kind of collaborative contribution to these GE configurations could maybe foster similar sort of things in perhaps a bit more of an organic way between sort of different collaborating organizations.
Sounds a great deal going on. We're coming to the end of our sort of formal time. We always have an informal period afterwards, but before we sort of make that transition, is there anything else you want to convey? I'm looking particularly at Patrick. Is there any messages you want to pass before we close off?
Well, I think we made most of the points. For example, that fair compliance is not always mandating open source. But I think, I think what we also need to make more clear, more publicly visible over the next year or so is what the benefits are for companies and platforms to federate through APEx. Because there are benefits. It's not only, the visibility of your application algorithm, it's also, nice tools that we have not mentioned so far, which is, for example, the APEx upscaling framework, which will allow you to point to one of the algorithms in the catalog, and APEx, the dispatch API that the APEx team has developed, will basically facilitate the upscaling of a very large geographic areas by doing all the sub-job management and retrieving a fully engineered end result for you. And this is a key improvement to the whole ecosystem, because even in Google Earth Engine, it has been very challenging to scale up algorithms over very large areas at full resolution. That always required dedicated engineering work. So there's really a lot of benefits for companies and platforms to federate through APEx, and I think that's how we need to present it. It's really an initiative for the community and the Earth observation sector at large, not for a consortium or an ESA project. Yeah.
Okay, well, thank you very much for joining us. Thanks to all the participants to the EOcafe this afternoon. I think it's been an interesting discussion, quite a lively discussion at times, particularly in the chat. That was great. We always like to see that. So thank you, Patrick, Bram, and Dan for being with us and telling about APEx. Maybe we should pencil in to call you back in a year or 18 months' time to understand a bit more what's happening. So we'll close the EOcafe at that point. Next EOcafe will be on the 25th of June, and we will be talking about national user uptake strategies, focusing on one or two countries, and this could become a series of meetings in the EOcafe. And then two reminders. Stefan Urovic put into the chat earlier that any ERSC member who's with us, please vote for your board. That will be finalised in June during the Expand EO meeting, or just ahead of the Expand EO meeting. So please, any ERSC member who's with us who hasn't voted for the board, for the directors for next year, please do so. A very important point that Stefan raised. And then finally, it flashed past on the screen there, the industry survey. We really do count on your responses. It's a very important survey. The results of the survey are used by ESA, they're used by the European Commission, and the more responses that we can get, the better. So please, if you haven't responded, then please do respond. And we count on you for doing that. So at that point, we close the formal part of the meeting. We'll leave the line is open. Anyone who wants to jump in and just say something, please feel free to do so.